Alright, great. So folks, today we will cover logarithm and then we will cover surds. Together you can expect somewhere around 2 questions out of the net 22 from what we are going to cover today. So it makes it a very important discussion for us. Let's start with log. What are the basic rules of log? Before that, what even is a log? So the definition itself provides a lot of answers. If you have a to the power x is equal to m, then you can say that x is equal to log m base a. So when you are given a log, it simply means what is this number a, which is your base, and what power should I raise it to get a number m. That is what log is. A being base makes it intuitive to understand this, because even here also we call this as base. So to what number this base should be raised so that you get the result to be m. Now while negative number raised to a power can give you a negative number, so technically a and m both can be negative. However, in the way log is defined, by default we assume that a and m cannot be negative. So that is the first thing. A and m have to be greater than 0. They can't even be equal to 0, because a base of 0 makes no sense, because you raise 0 to any power, it will give you what? It will give you 0 only. And similarly, to arrive at a number 0 by raising something to some power, it is not possible. You can get very close to it if x is very high and a is less than 1, but you can't attain it. So a and m have to be greater than 0. What other values are not allowed? A cannot be 1, because if a is 1, then doesn't matter what you raise it to, it is always going to give you your result to be 1. So a is equal to 1 is also not allowed. So these are the two constraints that we are going to deal with. Can m be equal to 1? M can be equal to 1, because any number a to the power 0 will give you 1. So m can be 1. Alright, so let's proceed. Log 1 base a is always going to be 0 for all a. Now when I say for all a, I obviously mean that this preliminary constraints that we have put in are already in place. Log a base a is always going to be equal to 1. If you want to get a result of a by raising a to some power, what will you raise a to? A to the power what is equal to a? The answer is 1. These are two basic rules of logarithm. Not as much as rule, just definition. Now let's focus on the second rule family. This is very important. Product or division. So log of product of two numbers is same as sum of log of those two numbers. The base will have to be the same. This is a very important property. We'll get to why. Right. Similarly, if you have log m divided by n and you want to take log of this to base a, you will have to write it as difference. Log m base a minus log n base a. Again, if you are looking for some memorization trick, you would know that addition and product are belonging to a similar family, which try to increase your number. So that can be a trick to remember this. However, I don't think you need that, because it's a very simplistic result. You might as well commit to your memory. This is something you most probably will end up using in the CAT exam if a log question comes, which is a very high possibility. Moving on, let's move to the power family of results. So I have log m to the power n, and this entire m to the power n, I am taking a log of this to base a. Using this fundamental result, writing it as sum n times, I will get that log m to the power n base a is actually equal to n times log of m base a. The trick to remember this is you take this n and place it outside, and the remaining is your whatever is remaining will get multiplied to n. So from log m to the power n base a, I will put this n down here, and what am I left with? Log m base a. The similar result is true for the base also. Now log m to the base a to the power n. Now I am raising the base to some power. So because base is downstairs, it is corresponding to the denominator. So again, this is a memorization trick. This is not how this result is derived, right? So you will take this n out and place it with the denominator. So the numerator will become 1, and what are you left with? Log m base a. The third result is called as switching, or rather exchanging the base with the power. So if I give you something like a to the power log c base b, I can switch c with a, and the proof is simple. You take log base b both sides on this and this, and you will end up at something which is same by using this property. Again, proof is not important right now. So you exchange c and a, you will get c to the power log a base b. Are the rules clear so far? Basic is actually definition itself. These two are very important, and this is definitely going to get used. Most probably this will get used. I mean, if you want to take a screenshot, you can, but I will put this on YouTube also, right? So you can take a screenshot from there. Let's, proceed with speed here. Time is of essence. All right. Now the inequality part of log. Now, generally, when you get asked inequality questions in log, it would not be a pure inequality question. It would eventually run down to this: the inequality, the process of making that this should be greater than that, etc. That is not something we are concerned with right now. That's a whole separate topic, right? Inequality can cut across different algebra, arithmetic, geometry, etc. However, if you have log b base a is greater than log c base a, before you make the conclusion b is greater than c, you need to ensure that a is greater than 1. Because if a is less than 1, if a is lying between 0 to 1, what will you have? A number a which is between 0 and 1 is getting raised to a power to get some value which is greater than a to the power c. Now the exponential growth, it switches when the base is less than 1. Simple analogy, 1 by 2 to the power 2 is actually going to be greater than 1 by 2 to the power 3. Whereas 2 to the power 2 would have been greater than 2 to the would have been less than 2 to the power 3. So the inequality changes sign when you switch your base from greater than 1 to less than 1. So if this happens, if your base is less than 1 and you are given this result, you will write the opposite, that b is less than c. This is a very fine point, unlikely to be asked, but if inequality plus log comes, this will be used at the end towards the last step, where you probably will be less careful to begin with. Alright, final family of rules, base change. This is something you need to master, because when I said that product or division gets used, it generally gets used after you apply the base change things. Alright, so these three families that we discuss, product division, power, and base change, they are not generally used in isolation. A good log question, a difficult log question would use two of the three or all three. Although looking at the trend of questions, in your past year CAT exams, log is generally very easy. So they sometimes even do ask one family question. Alright, so if you have log b base a, alright, I can write this as log b base c divided by log a base c, where c is any random number. Now when I'm saying any random number, what does that mean for me? that I have the room to be creative. I have the room to decide what this C I can take as. Doesn't matter what this C you take. You can take it to be 2, 3, 4, 5, whatever you want. You can take it to be 1.77. Doesn't matter. So CAT will try to exploit this. They would want you to be imaginative enough to convert it into this format where the C is something which will help you solve the question. So the only way where your creativity can be tested in log is this area. Other than that, it is rules and certain memorization, which we are going to do shortly. Using this argument itself, you can also write log b base a as 1 by log a base b. Now the problem with these two results in the way they are written is that generally this is what you have in the question and this is what you have to convert it into. So while every textbook that you see is going to say that this is equal to this and you memorize it like that, the application is actually that this is equal to this and this is equal to this. When you look at the last result that we have, log b base a is equal to 1 by log a base b, do you get the sense that if they give me log in denominator, I can get rid of the denominator by switching the base with the argument and writing it like this? Because think about it, if I add 1 by log something plus 1 by log something, this is going to be a difficult calculation, right? Because I don't know the log values for a lot of numbers. So, and most log numbers are not going to be integers. Only perfect powers of 10 are going to be integers. Yeah, default base is 10. So, only perfect powers of 10 are going to be integers. So, in such scenarios, more often than not, this is going to be useful. Are we all good with all the rules that we have discussed? Now we will move to the level 2 of the rules. Alright, so product division rule. The rules are on your screen. I have only 2 tips for you. First of all, base should be same for reverse application. So this result also generally not gets used as this converts into this. You generally have this in the problem statement and you have to convert it into this. To do that, you have to ensure that the bases are same. If the bases are not same, what is it that I can do? I can make use of the rules of the other two family, which is the power family or the base conversion family. Correct? We will see that. Secondly, generally questions which have multiple terms make good use of this. Because if you have log plus log minus log or something like that, the only way to do this, mathematics is by combining the argument. And how do we combine the argument? By taking this and converting it into this. Are the two, applications clear to you? Alright, so then let's look at this question on our screen. So you have been given that if x is greater than 1, find the minimum value of this 5 log expression. Now, dealing with 5 different terms, each with a variable x, it's going to be difficult. I hope you all, appreciate that fact. Which means I need to reduce the number of terms. This is how my mind is working. Now, how do I reduce terms? Which family helps me reduce the terms? This family, 2 terms becoming 1, 2 terms becoming 1. Yes, alright. So, now when I want to use this family, I need to make sure that base should be same. So, the base for this term is 30. For the rest of the terms, it is x. So, I can combine these. So now when I want to combine these, I have these coefficients sitting here. How can I get rid of these coefficients? By sending them inside to the argument. So this term will become log 5 to the power 3 base x minus plus log 10 to the power 20 base x minus log 6 to the power 3 base x plus log 3 to the power 20 base x. Now I can take the base common. So now let me write the terms carefully. Which two are positive sign? The second term and the last term. So they will go in multiplication. So they will go on the top, 10 to the power 20 into 3 to the power 20. The other two terms are negative, so they are going to be this denominator because the minus sign is here in front of the denominator. So you will have 5 to the power 3 and 6 to the power 3. Does this whole thing 10 into 3 become 30? So is this 30 to the power 20 divided by 30 to the power 3, which becomes 30 to the power 17, and I am taking log base x. So this entire thing becomes what? Log 30 base x multiplied by 17. So far everyone is with me? Great. Now this is getting added to 17 times log x base 30. 17, it is God's plan. This should have happened because the 17 seemed a very arbitrary number. Now let me take 17 common. I have what? Log 30 base x plus log x base 30. Is it time for my favorite thing in quant? Yes, because this is, if this is y, then this is what? 1 by y. 17 into y plus 1 by y, I want to minimize this. So the minimum value of this is going to be 2 through AMGM. So your answer is going to be 17 into 2 is equal to 34. So someone said 2 as the answer, you forgot the 17. So the answer for this question is going to be 34. You forgot to multiply, that is correct. So, yeah, you can take common, you can take 17 common because this is a number and this is also a number. At the end, all logs are going to be numbers, right? They are coefficients. So you can take the coefficient common. You can spread the coefficient also. If this was given to you 8 into log x plus log y, you could have written this as 8 log x plus 8 log y. Your general arithmetic rules are going to be respected. These are just some additional rules on top of it. Alright, let's move to the next question. Now, I am looking at this expression. They are asking me for the value of 100x. I have 1, 2, 3 terms. This term has a base of 10. This term has a base of 10. This term also has a base of 10. Now, one thing that I can do is take everything, this and this on this side. Have all the terms with base 10 on the same side. You can proceed with that. It will not change your method. However, one thing I want to, highlight is you can convert a constant also into a log, because 5 is what? Log 10 base 10. 5 into log 10 base 10, because log 10 base 10 is going to be 1. So you can then send this 5 inside and say this is log 10 to the power 5 base 10 minus this plus this is equal to this. Now I can combine these three terms. This will become 10 to the power 5 because it has a positive coefficient into root 1 minus x to the power 4 because you have a positive coefficient divided by root of 1 plus x. This entire thing to the base 10. This is equal to log of 1 by root 1 minus x square to the base 10. Now bases are same and you have equality, which means this entire thing has to be equal to this entire thing. So you can simply rub your mod out of the log out of the equation, and once you manipulate this you will get 100x is equal to 99. So I'm not solving it further. This is what our target was to arrive at this result. Alright, clear? Alright, so then let's proceed to the second family, power. The results are in front of you. The only two additional points that I have for you is powers might be shown or they can be hidden. What do you understand by hidden? Do you know what this number is? 0.125. This number is 1 by 2 to the power 3. This is your hidden power. So these things can be done in front of you. So there are some numbers that we will have to memorize, and now is the time that we should just get over with this. So that moves us to our memorization toolkit. First of all, these are the powers that you absolutely must remember. For everything else you can go with knowing the squares till 30 and cubes till 10. Apart from that, for 2 to the power n you need to know this entire family, because this thing gets used in many different topic areas, not just log. This gets used in your PNC also, a lot of different places. Similarly, 3 to the power n, where n is 1, 2, 3, 4, 5, 6. So these 6 numbers you should know. What I mean by you should know is that when you see 729, something inside you should click that this is an extremely familiar number. I know this number, and this is 3 to the power 6. Similarly, the first 4 powers of 5. These 4 also you should memorize. So this is something you need to memorize. You can take a screenshot from the YouTube video later. Secondly, you should also memorize some of the decimals as well. So 1 by 2 is 0.5, 1 by 4 is 0.25, 1 by 8 is 0.125, and 1 by 16 is 0.0625. So if your denominator is in powers of 2, what are the decimals? First two, I think everyone knows. This one also at this stage of your prep you would be knowing, hopefully, and this last one also you can just add to the kitty. Apart from this, for 5 also you should know. So 1 by 5 is going to be 0.2, 1 by 25 is going to be 0.04, 1 by 125 is going to be 0.08, and 1 by 625 is going to be 0.0016. As you can see, obviously, because 2 into 5 is 10, so these are inverted, right? 1 by 2 is 0.5, so 1 by 5 is 0.2. 1 by 4 is 0.25, so 1 by 25 is 0.04. Alright, lastly, these 4 things also you should be knowing. Most probably, if these values are going to get used, CAT would give you those, that log 2 base 10 is equal to 0.301 and log 3 base 10 is equal to 0.477, right? However, as an extra step of safety, you should know these 4 for the first 4 prime numbers essentially. The reason being that if you ever get asked a number of digits question, you can use this there. Again, a slide is upcoming on that. So maybe they ask you a number of digits question, right? And it's not related to log, so they don't give you the log value, but you identify that taking log can help me answer this question. I just need these 4 values. So they would not have provided that. So it's a good practice to know these first 4 values. Secondly, sometimes your options might be, in terms of log 2 plus log 3 or something like that. Obviously for the prime numbers we are considered, because the rest you can convert. You don't need to memorize log 4, because log 4 is going to be what? 2 times log 2, because 4 is 2 square. So you bring the power down in front of log 2. Alright, so these are your memorization toolkits. These are the things that you should memorize. Alright, so let's proceed. Let's try and do this question. Now, immediately this looks like this looks like a chunky question. There's a lot of things happening here. Now, what do you see? Do you see 7 to 9? And 7 to 9 is what? 9 cube. And do you see a 9 placed under it? So I will convert this 7 to 9. So what I'll do is I'll first take this power down. So I'll write as x square minus 7x plus 6 into log 7 to 9 base 9. This entire thing is getting raised to the power 3 by 5. This is my expression. So this becomes what? This is 9 cube, this is 3 to the power 6, and this is 3 square. So this thing will become 3. So you are getting 3 to the power 3 by 5 into x square minus 7x plus 6 to the power 3 by 5. This is what you are getting on the RHS. On the LHS, what will I get? Alright, so this 5 will come down here. So I'll get 5 here. Then I have log x square minus 2x minus 1 and 5 to the power this. So this will also come down here, x square minus 7x plus 6 into log 5 base x square minus 2x minus 1. This is what I am getting. Uh, yeah, can you repeat, Drona? Yeah, yeah. So, but 9 and 7 to 9 is what? Okay, okay. So 7 to 9 is what? 9 cube. Yeah. All right. So now at this stage, you can cancel this out with this. You will get this as 2 to the power 5, right? And this 5 will go here. So you have log into something is equal to some constant, correct? Uh, Now, in the act of cancelling this power, did I remove this as a solution? Because if I'm cancelling this, I'm saying that this is not equal to 0, which means that this is equal to 0 is also one of the solutions, which will give me x as 6 or 1. X is equal to 1 is not going to be allowed because you have x square minus 2x minus 1 in the base. If you put x is equal to 1, your base will become negative. So you will get 6 as your answer. Because they are asking you for, one integer answer only, you will mark 6 and move on. No need to solve this x square minus 2x minus 1 in the base log. So this was just for trap. The purpose of this x square minus 2x minus 1 was to reject this x is equal to 1 case. The final answer is 6. Are we clear on this? Alright, great. So let's move ahead. One more question. Alright, so you see a lot of powers on either sides. What are the observations? Yes, Aniket.
Yeah, sir. Sorry. In the previous question, if you could just scroll
Yeah.
up. Yeah. Over here, I just wanted to clarify. Over here, we have log 9 raised to the power
No,
3
no,
by
no. So that is the syntax error. This 3 by 5 is actually to this whole
Okay, for
log
the
term.
whole.
Yeah, this
Okay,
is to
okay.
the whole.
Sorry, sorry. I got confused.
Yeah, yeah. No worries. All right. In this question, what are the observations that you can make? What are the four numbers that you see? 16 power of 2, 81 power of 3, 27 power of 3, 8 is power of 2. It makes sense to convert everything into powers of 2 and 3. So you will write this as 16 by 81 whole is being raised to the power 2x minus 5 by 3. This is equal to 27 by 8 whole to the power x minus 11. So I will write this as 2 to the power 4 and 81 is 3 to the power 4. So I'll write this as 2 by 3 to the power 4 into 2x minus 5 by 3 is equal to uh, into 3 for what? Sorry. This is cube root, right? So this will go in the denominator. This will not get multiplied because this is a cube root, right? So it will go in the denominator as 1 by 3, right? So this 27 by 8 will become 2 by 3 whole cube, but minus, because I am bringing this 8 to the you know from denominator to numerator. So this will become minus 3 into x minus 11, right? So that will become 3 times 11 minus x. So you can now, because the bases are same, which means the powers has to be same, because the basis is not 1, it's a constant number which is not equal to 1, which means that the powers have to be same. So you can now equate the powers and you will get your answer. Tushar, what's your doubt? All right, final question for this family of powers. Again, what do you see? What is this number? This number is 5 to the power minus 3. So you have log of 5 to the power 1 by 2 to the base 5 to the power minus 3 plus log of 3 to the power 4 and 3 to the power 1 by 2 minus 7. So this will become what? 1 by 2 into minus 3 plus 4 by 1 by 2 minus 7. Correct? and whatever this turns out to be is going to be your answer. I think this is going to be 8 minus 1, that is 8 minus 7 is equal to 1, so this thing becomes 1, and 1 minus 1 by 6, so this is going to be 5 by 6. This is your CAT question. So this is the level that is expected in some shape or form in this particular topic area. All right, we move ahead now to the okay, one last question in the power family. All right, 13 to the power log 872 base x is equal to 5 to the, I'll just write this expression if the it is not clear, is equal to 5 to the power log 961 base 25 plus 7 to the power log 29 base root 7. Now what can we do? You can observe the powers, you can see the powers that 961 is 31 square, but that is not inherently helping you right now. What is more prominent here? This scenario, right? This is 25 and this is 5. So while you don't know the value of log 961 base 25, you know the value of log 5 base 25. So I will do this switch here. Similarly, I will do this switch here. So this side will become 961 to the power log 5 base 25 plus 29 to the power log 7 base root 7. So log 5 base 25 is going to be 1 by 2. So this becomes under root of 961. Log 7 base root 7 is going to be what? 2. So this becomes 29 square. So you get 31 plus 29 square is equal to 13 to the power log 872 base x. And I can bet my life this is going to be 872. Right, so this turns out to be 872. So now you will again switch, you will get 872 log 13 base x is equal to 872, which means that the power must have been 1, which means log 13 base x is equal to 1, or x to the power 1 is equal to 13. So your answer for this will be 13. Yes. All right, finally base change. Now I have already discussed two use cases of the base change thing. Number one is it is used to bring the log from denominator to numerator. It is almost also always used for either cancelling the product, which uses the first definition, or it is used to facilitate the product division format, because as we saw, product division would require, or the power thing, all of these things will require the bases to be the same for you to be able to club certain log terms together. So if I look at this question, what do you observe? Do you see that if I write this as log b by log a, I am taking the base as 10, into log c by log b, into log d by log c, so on till log z by log y. This cancels, this cancels till this point. So the only terms that will remain is a, which is in the denominator, log a in the denominator, and log z in the numerator. So your answer will be log z base a. Now how do I find that? They have given me this. A, B, C, X, Y, Z are 26 natural numbers in GP. So you can express Z as a power of A. So you can say, yeah, you can arrive at the answer after this, right? A is equal to 2 and Z is going to be what? 2 to the power 26. Yes, so if you take the log, then you will get 26 as your answer. Alright, next question. This is your CAT question, by the way. You are seeing so many log terms, but all the logs are in denominator. Can you really do anything? Let's say if you don't know how to change the base, can you really do anything? You can't. But if you look at this number, is this not log 2 base 100? And is this not log 4 base 100? And is this not log 5 base 100? Now you are getting the bases as same, which means I can now operate on this. So I will convert each of this, removing the denominator, converting it into the numerator term format, and then what will you have? You will have multiplication and division. So this thing is going to be log 100 in the base. What are the terms with positive in their coefficient? 2 into 5 into 20 into 50. What are the terms that have negative? Which is 4, 10 and 25. So do you just do this math further. So you get log 10 base 100. You can get the answer from there. Alright. Uh, Final words of wisdom. This is something you should, or you can know, you can memorize this now, so that you use it in CAT if at all. Unlikely. Number of digits for any number, n, let's say any number n is given to you. Let's say I give you 2 to the power 7 into 3 to the power 5 into 5 to the power 16. I ask you what are the number of digits in this number. You can simply find the log for this, log base 10, because you know this will become 7 times log 2 plus 5 times log 3 plus 16 times log 5. Because you have memorized these three values, you will be able to find what this value is, which will be of point something something format. You will then take the greatest integer function of this, you will remove the decimal, and with this integer you will add 1 and you will get the number of digits. You can try that for a easy number as well, your 999, for example. Now if I take log 999 base 10, I know that the answer is going to be between 2 and 3, because 10 square is 100 and 10 cube is 1000. So log 999 base 10 is going to be 2 point something. So I will now take the greatest integer function of this, which is 2, and I will add 1 to this to get 3 as the number of digits. 1, 2, 3. It does have 3 digits. So the working of this, why this turns out to be, is not as important as that it actually works. So that is going to be so what I'm saying is, if you want to find the number of digits of some number, you take the log of that number to base 10. Now log 999 base 10 is going to be what? I don't need to, I can find the exact value also, right? For this probably I cannot, because 111 I don't know the value of log base 10. But I know that 999 is a number which is less than 1000 and greater than 100. 100 is what? 10 square. 999 is 999. 1000 is what? 10 cube. Which means when I take log base 10, this will become 2, this will become what I'm looking at, and this will become 3. So log 999 base 10 is going to be between 2 and 3, so 2 point something something. So once I get that, I will take the greatest integer function, that is going to be 2, and I'll add 1 to get to the number of digits. You also sometimes get this sort of question where generic expression to expression conversion is there. So again, there's no set rule for that. You will have to use the rules that we have set for ourselves, the rule families that we have to your advantage. Generally, base change into product division and power family can be used. Finally, you can use the option also, because they will give you 4 options. You can manipulate those options and see, but this could be lengthy, although this will definitely give you your answer. Alright, so that finishes log. I hope this adds a certain level of structure in the log discussion, right? So you don't have to think of log as a something related to algebra. In all honesty, it's more arithmetic than algebra, or rather it is arithmetic of powers, right? So as long as you understand the 4 rules family that we have set, you should be okay. So let's move to the next topic, which is surds. This is generally your numbers of this format, where you have a plus b root n sort of things going on, where you have a rational part which is your a, and you have an irrational part which is irrational because of this root n. What irrational means is that you cannot express it as n by d format. And for you, for practical purposes for CAT exam, irrational just means under root of something which is not a perfect square. So because it is not a perfect square, the under root would not turn out to be something which terminates, right? So there are 4 rules that we would like to see here. Rule number 1 is, if I have a plus or minus b root n, and if I am squaring them, so what I can do is literally do what is being asked. I will square it. I'll get a square plus b square n plus 2ab root n. And once I do that, I can compare the coefficients. So I can compare that a square plus b square n is equal to c and d is equal to 2ab. And the reason why I can compare it is again plus minus. Yeah. So if you take, if this was plus, then this will be plus here, and if this was minus, this will be minus. Right? You can compare, and the reason why we can do that is because root n, which is an irrational number, the multiplication of that, wherever root n is going to be, it is going to be the same on both sides. You can't say that this c hides some value of root n. It would not be able to do that because c is a rational number. So bottom line is, when you raise a rational plus irrational to some power, the resultant is also going to be a rational plus irrational. Alright, so this is your last year CAT question only. A plus b root 3 whole square is equal to 52 plus 30 root 3, where a and b are natural numbers. Then a plus b equals what? Now you have root 3, which is irrational, which means if I whole square this, I'll get a square plus 3b square plus 2ab root 3 is equal to 52 plus 30 root 3. Now this root 3 term has to be same with this root 3 term, which means 2ab is going to be 30 or ab is going to be 15. Secondly, I will have a square plus 3b square is equal to 52. Now I have to solve these two things to find what a plus b is going to be. However, we have still not made use of this natural numbers thing, which I can use now. A b is going to be what? 15 into 1, 1 into 15, or 3 into 5, or 5 into 3. So obviously if a is 15 or b is 15, this entire thing is going to be at least greater than 225, right? Which means 15 wale factors are going to be out of the window. So you have one as 3 and the other as 5, so the sum is going to be 8. Signs on the opposite side different. If it is asked, Atharva, then your b will turn out to be negative, no? Because then what you will get? You will get 2ab is equal to minus 30, let's say. Then b itself will turn out to be negative, which would essentially mean this being a this sort of question, right? So they will keep the sign same. Second rule is finding the under root of a surd, a rational plus irrational, and you have to find the square root of that. So if you can't under root something, can I square it instead? I can square it instead. So what they are telling me is, in this particular question, that a plus b root n is under root of 29 minus 12 root 5. Correct? Now I can either solve this, what this turns out to be, or I can square both terms. I'll get a square plus n times b square plus 2ab root n is equal to 29 minus 12 root 5. And after that it is going to be the same thing. Correct? So far, are you guys with me? Now to the actual part why I have included this question is, when we are going like this, when it is given to us that a plus b root n whole square is equal to c plus d root n, I don't need to apply my brain because root n is root n. On both sides, I was having root 3 and root 3. So these were going to be equal to each other. However, think of it like this. Can 12 root 5 also be written as 4 root 45? Can I write 12 root 5 as 4 root 45? And if I can do that, how do you know root n is going to be root 5 and not root 45? So in that situation, you will have to take cases. So which is why this entire maximum possible value argument was even in picture, because n could have taken multiple values corresponding to which you would have had multiple values for a, b and n. So the maximum out of that is what we had to find. So you can make cases for this and you can proceed with, run with that. All right, so far with me. The other way is, let's say I have to find the root, right? uh, I have exact numbers given here, so I might feel like finding the root directly, because this is root plus root. What I'll do is I will identify this 16 as 2 into 8 root 3. Correct. Now I want to express 28 as a sum of a square plus 3b square. Because it is going to turn out to be a perfect square, I can write 2 8 root 3. I will separate this 2. I will land at 8 root 3, and this 8 root 3 I can express as a into c, where c is equal to root 3b, because this root 3 needs to be part of one of the terms of a plus b root n, right? So I can write this c as root 3b. So again, all of these things you don't have to write, these should happen in your mind. And something like this. I have to make 8 root 3. Let me check. 8 square 64, root 3 square is 3. So it's definitely not going to add to 28. Let me try the next. 4 and 2 root 3. 4 square is 16 and 2 root 3 square is 12. 16 plus 12 is 28. Which means yes, I have arrived at my answer. So this thing is going to be 4 plus, or rather minus 2 root 3 whole square. And you can check now. 4 square is going to give you 16, 2 root 3 square is going to give you 12, 16 plus 12 is going to give you 28. So far so good. And minus 2 into 4 into 2 root 3, which is going to be minus 16 root 3. 2 into 4 8, 8 into 2 16. So if you can do it like this, this has to happen mentally. Similarly here you will get 4 plus 2 root 3 whole square under root under root. So under root and squares will cancel out. 2 root 3 will cancel out. Your answer will turn out to be equal to 8. So far with me? Alright. This is the smarter and the fastest approach. But let's say you are not able to think of it. Let's say you are not able to, for the life of your, whatever, you're not able to figure out how do I factorize this. The another method is you put it as x and you square it, which will give you this square plus this square, which is going to be 28 plus 28, which is 56, minus, or rather plus 2 times root of 28 square minus 16 square into root 3 square, which is 3, is equal to x square. And this would turn out to be a perfect square. You could also have shifted one of them to this side and then squared, but if you had done that, you would have ended up with a x term also. So why do you want to deal with that? Because the question is already hinting, this is a theta question, the question is already hinting that this has to turn out to be an integer. So why not just square it, and this should turn out to be a perfect square, which will give you your answer. So this was the last thing that I wanted to discuss. We have already covered this in the last slide, right? You can just square the entire thing. Now, obviously, in this particular scenario, what was the method one in the previous question? I can't do that because I don't know what x is. That's exactly what I have to find. So because I don't have the rational part, I don't know how to factorize this irrational part and arrive. So I only have one solution here. I'll square this. So you will square this. You will get this entire thing square, 6 plus root 6 x plus 6 root 2 plus this entire thing square, which is x minus 6 root 2. So basically this root 2 is cancelled, and then minus 2 times x square minus 6 square 36 into 272, this whole under root, is equal to 8. 2 square into 2. So now you can take x on the other side, because you will now have 2x minus 8 is equal to 2 root x square minus 72. When I square this thing again, right, the x square term here and the x square term here will cancel, and I'll get my answer directly. At this situation, you can also just maybe take an educated guess. You want x square minus 72 to be an integer, right? So you can take a guess there also. If options were there, you could have used, but I don't think this was an option question, right? All right. The final thing is, and this is something which can get used. X is equal to 9. 9 to I don't think it's going to be 9. You can just cancel this. X minus 4, this is cancelled, this is cancelled. You will get x square minus 8x plus 16 is equal to x square minus 72, right? X square cancel. You will get 8x is equal to 16 plus 72, which is 88, or x is equal to 11. X is equal to 11 will be your answer. Yeah. Final thing on this topic, conjugate pairs. It's a very underrated thing. If you have something like a plus b root n, what should I multiply it with to get a rational number? Basically, what should I multiply this with to get rid of root n? I should multiply it with a minus b root n, which will give me a square minus b square n. There is no under root here, so this is a rational number. So generally things like this, root 2 plus 1, you know what root, you are comfortable with root 2 plus 1. What if I give you 1 by root 2 minus 1 as one of the options? Do you know that both of these are the same things? And how do I know that? Because if I multiply both with the conjugate pair, which is going to be root 2 plus 1, what will I get here? 2 minus 1, which is 1. So this denominator will cancel and you will be left with this. So both of these things were actually the same thing. So always remember, multiplying with a conjugate pair will convert it into a rational number, and the application is generally like this. When you have something like let's say you have 3 minus root 2, for example. I don't think 3 minus root 2 is a good example. I want something like let's say 3 minus 2 root 2. If you have 3 minus 2 root 2, you want to deal with this. Let's say this is getting added to something and some other things, right? And everything else is fine. This one has an ugly denominator. It is possible to get rid of the denominator by multiplying with the conjugate pair. What will be the conjugate pair of 3 minus 2 root 2? 3 plus 2 root 2. And when you do that multiplication, you will get 3 plus 2 root 2 in the numerator, and in the denominator you will have 3 square minus 2 root 2 square, which is 9 minus 8, that is 1. So this will get rid. This something will get rid of. This also helps in your geometry options as well. Alright. So alright folks, this covers both the topics log and surds. In a good CAT exam paper, you can expect 2 questions from these 2 topics, and it is sort of a gift to you, because nothing from these 2 topics are going to be difficult per se.